normally, this would be wired as a normally open switch.
Now what is this again, Ken? I'm sorry.
This is the safety. It's an air pressure switch.
Air pressure switch, okay.
So it's normally wired in an open state. So meaning the circuit is not complete.
Okay.
Then when we get pressure into the switch, it presses against the diaphragm in here, and it actually closes a contact and closes the circuit to say, I now have proof that there's pressure in this cabinet, meaning the main blower fans are running. I'm satisfied. Now I start my timer for my purge timer, and it runs for the 4 or 5 minutes or whatever someone has it set on. When that timer expires, then that's one of the safeties that has to be satisfied before the gas valve opens and the flame igniter rod, or the spark plug in some cases, gets the electric signal to cause a spark to ignite with the gas in the burner chamber. So this is a typical airflow switch.
And they'll all look very similar to that.
Similar, yes.
Two hoses coming out like that on it, Ken?
Some do, some are just connected on one end. But in general, look for the capillary tube that would pressurize it, and then you'll know that it's the airflow switch.
Okay.
Now, one of the bad habits that this place has developed is when they work on things, they don't put covers back on the electrical components. So I have found multiple. Bless Ruben's heart. Ruben has been closing up as fast as I can find, and he's finding screws to put covers on. But for instance, Peter came up and put a different motor on the 10 for the rotating damper. And the junction box where the wire goes into the motor, that cover was laying there, and the wires were out in the open, wire nutted together. But you should never, as a mechanic, leave an open connection, ever. There's no good reason. So that's a very bad habit. I see it at several plants, and I beat them apart on it. There's two things. If you ever get someone that's less than experienced up here, it's another hazard that they're not aware of by just inadvertently touching something for getting injured.
And all these are stainless steel. I mean,
the conductivity is awesome up here. Yep. So another switch that's important for safeties, and different oven manufacturers go about it different ways. Some have a groove damper open. So that's your exhaust duct. Down here is a paddle that's attached to the damper shaft. Now, when that actuator motor, which is that rectangular box, on the back side,
over there,
actuates the damper in the open position, it then contacts the micro switch, which again is a normally open switch, closes the circuit and says, I'm happy. Another safety has been met. So now we've proven that we can exhaust air out if there's any gas buildup. We have the means of getting rid of it. We have the main blower running to help push it out. And then the other switch would be the combustion airflow switch, which is on the backside by the burner. There would be a combustion airflow switch that actually proves that.
Can you video that?
the back.
Yeah.
That's back here.
So I'll hop down here and point to it. So here's the air line that comes from the combustion air into the safety switch, which is another air pressure switch, and then exhausts back into the main blower cabinet that says, okay, before I open a gas valve and throw a spark, I have to have the air from the combustion air motor running. And this is the safety that proves that that's running.
All right.
So those are the primary safeties to say we we should be safe to strike an arc or a spark to open the gas valve and light.
Is that a 4-step process?
Well, it depends how it's wired. Some of your ovens have a single fan, so they'll have a single airflow switch on the main blower.
Okay.
Now, if we go over to oven 3 has dual fans. The next oven over has dual fans. So this one works a little bit different, where the fans are alternating. That's how they're getting their highs and lows on top of the rotating damper. Now, I don't necessarily agree with that. I would like to see the design where you have a main airstream source and the rotating dampers do the work. Some OEMs got very convoluted and overcomplicated designs where, for instance, on this one, we have a very low high velocity.
Okay.
And we're limited as to what we can expect just based on how the motor RPM was sized for this oven. It's not on a variable speed drive, so the only thing you could do to speed this up and get higher airflow, unless I'm missing something, is to go with different shifts or upsize the motor RPM so that we can get higher velocity. Now on this one, that big gray box on top is the variable speed drive. So all we did is take that up to 60 hertz, and now we're in the low 3,100 feet per minute high air velocity. That's going to give us a much more efficient cook in this oven than you guys have been doing probably.
This was didn't you value this at 30 hertz or?
Initially, this was running in low at 30 hertz.
Yeah, that's right. I remember
and it
that.
equated
50%.
to 1,700 feet per minute, whereas opposed
50%.
to now, we're at roughly 3,100.
Okay. Yeah.
So almost double the velocity.
But we still want to work on that and get that up to like 45, 4,600.
Not necessarily. Just because that's kind of a benchmark of what you can be that high and still cook the product that you're cooking. This may cook just fine at 31. I would exhaust optimizing this before I would say, you know what, let's look at the upside. But when I look at oven size and fan cabinet size, these two are almost identical. If you're going to put money in one of them, get this one to run faster.
Okay.
That one's that's not your Kentucky Derby horse,
Correct.
but that's going to be your plow horse. That's going to keep running.
The mule.
This one's going to be the broke down old nag that's just barely moving the plow across the field because of that low air velocity.
Okay.
So one of the problems I have with a lot of the ovens here is that we have an actuator motor on the oven that actuates the damper open and closed. Some of the ovens have the actuator motor missing and the linkage arm zip tied open. We have fresh air intake dampers that are in a static position. You could walk over there and inadvertently bump it and it would open or close more. Not the way
designed to run.
it was designed to run. There's mounting brackets, and simply through the years somebody said, you know what, probably not that important. I can save money on maintenance spend. Let's just zip tie them open. That way they're always open. Yeah, we might lose a little efficiency, or there's such a lack of understanding of how you effectively and efficiently run an oven that you totally discount. And I've seen this in other plants where I argue with maintenance managers that say, out of your 20 ovens, why did 10 have motors missing on your exhaust? Well, we've proven that they don't do that much. You know, there's nobody in that company quantifying what you lost in efficiencies by taking that out of line. All the oven manufacturers put things in place for a reason. There's engineering behind it. So again, you know, making those kind of tribal knowledge decisions and dumbing down the equipment is never really a good idea.
We just get these up to having the right parts and everything, we're going to be so much better.
Oh, absolutely. When we go over to the bank of ovens that 3 is on, there's a lot to talk about over there. This oven here, it appears they were working on the wiring to try and get some of the things corrected. Now, one other thing that maintenance seem to be aware of, but is a very dangerous situation. The oven you're standing on is oven 9. The oven to your back here is oven 10. When you hop down on this side, you've got a junction box here and here. You've got a Lamacoid on here that said oven 10 junction box 120 volt. This one said oven 9 junction box 120 volt. On the wrong label, on the wrong oven. So to prevent issues, because those Lamacoids, once you peel them off, the adhesive seldom resticks, I took a Sharpie and crossed out oven 10 and wrote oven 9 and fixed this one. When maintenance people see mislabeled electrical boxes, they need to take that very serious and correct it. Because here's what happens. You lock out oven 10, and you're in a hurry, you've had a long day, and it's down. You hop up here, and you get to here, and you go, well, that's oven 9. You open this up, dive in, you know you've got it locked out. Electrocution. So critical to have proper labels on your ovens, on your electrical components that match the oven number. And here was a big thing. Now again, this is oven 9, remember?
Yeah.
What does it say on that panel right there?
The 280 volts, or?
It says oven 10.
Oh. Yeah.
There's
Look at that.
the same panel for oven
This is oven 9.
number 10, and it says oven 9. I haven't marked those, I just noticed it that we're on this subject, but that's something that I would strongly say that I probably shouldn't correct. It should be something that maintenance owns and goes through and verifies the proper labeling on all these electrical components. Real simple to trace the conduit from here to prove that it comes to this oven and not that oven, and that box doesn't come to this oven, it's for that oven.
But it's just the same if our maintenance guys know that, but we may bring in a vendor, and he doesn't know 9%, and say, hey, it's up here.
Yeah.
That's what happened to me. I wasn't in the panel, but I was up here doing a checklist and went, I could have swore this was oven 9. No, okay, so I even changed my notes, and I went back down, and I looked at the doors, and I went, holy cow, these panels are marked wrong.
Something as simple as that can be catastrophic.
That's where the bad things really can happen, because nobody really thinks about things like that.
Sheesh.
Again, even talking about training, going through the ovens, and a hands-on training how we egress safely to get out of an oven if someone shuts the door.
Right.
Part of what we need to be using for the orientation training for anybody that's maintenance or operators around the oven.
Agreed.
All right, I'll climb out again.
You
Need some little stairs and stuff too, huh?
No, I got it.
got it.
I've found that if I take my time, I can go anywhere.
Yeah.
It's when I'm in a hurry that I hurt myself. So again, here's another example of the damper right now is assumedly closed because the switch is open.
Yeah.
So then
It's nice
when
to
this
have the linkage.
when this would make, it would close the circuit. The part that bothers me is all these should have a ground timing mark on to verify that when that shaft is in a specific position, it matches the phasing of the damper. I talked to Harry about that. He said after shutdown they will all have it. So please follow up on that one because it's critical to the operation and to the safety.
I'll get a copy of your video.
Oh yeah, I'll
I'm going to cut right off.
So an airflow switch where it just has the pressure from going in and it's exhausting. That's what it means. Right. A lot of those airflow switches, sometimes they'll plug one to the pressure side of the fan, main blower cabinet. Remember with any fan, there's always a pressure side and a suction side. So if they have trouble with low static pressure, then a lot of times that's why the switch manufacturer will make a pressure side and a vacuum side. So one's pulling and one's pushing at the same time, and it makes the switch much easier. This one is coming off of the cabinet here. That probably gets plenty of pressure. Yeah, it's just a capillary tube that. So what you would have seen before today is several actuators and stuff with covers on. Ruben had put a bunch of those on back in place, so we're in a lot better shape than we were. Another thing to talk about, for your fresh air intake that goes on your food, most plants have filters, and they change them quarterly. If you notice, on like that one, where the intake is, you can simply lay a filter on top. Here, probably a little harder. They didn't really design it too well. On some of your ovens, when you get over there on the vertical intake, they actually have the filter slots, so you measure it up and you just buy the filter. Now it's not to get real fine, but as we go around and you see how dirty some of the intakes are, that's direct food contact going right on the top. And I'm not telling you to get it, but I'm saying most plants have it.
I asked them before what
Right. Cottonwood, it's terrible. Yep. Now, there comes a huge responsibility when you take the step for filters. Make sure that you're on a regular PM and someone's paying attention. Because what happens is as they choke off, now you're starving the oven, and for things like when you're trying to safely purge an oven before you light it, it's like having the damper closed, because now you can't get any air through it. So, you know, it's a double-edged sword. It should be filtered, and it has to be maintained. Yeah. Yeah. Now you talked about steam. There's a lot of steam piping here, and according to Peter, Ruben had a conversation with him where they tried steam, didn't like what it did, and they cut the pipes and plugged the holes going into the oven. You've got a lot of your infrastructure on certain ovens. So when Mike would come out and you show him an oven to do, you might want to consider where you already have a working psychrometer pan in and some of the steam line running ready, because you're halfway there. Yep. Yeah, but like all this is steam. Yeah, the other thing for the plant, the PIDs, they should be labeled clearly, at least with the decals, so that there's never a bad thing that happens when somebody cuts into a live steam line, thinking it's a water line or an air line, and so on. And that, you know, moving into a plant and setting it up, it kind of gets overlooked initially, but it's a discipline. Go back and get everything properly labeled and update the drawings. There should be, you know, your piping drawings for the plant. So if there's ever an emergency, you know, there's things like that that really become important to know where the hazards are. Now, your refrigeration on site here is not ammonia, is it? Okay, so you're not under DSM. Okay. Because I noticed today when we had those oven cones that needed to be welded in, there wasn't anything about a hot work permit or anything like that. So I don't know. Okay. Yeah, and we had a form that we used anytime that we worked on equipment that was considered full contact. So for instance, we would have a management of change form. If we were going to go into an oven and weld something, then the airflow would go past or contact that surface and touch the product. It was a management of change, so that number one, we looked at how it would affect the machine, and then food safety and operations and maintenance, and the safety guy would all have to sign off that it was done properly and cleaned up properly. What plants run into, what plants run into is that it's midnight and we're down and they fix it, and the guy leaves the pieces of welding rod laying on the machine, and now they trickle into the food chain, or things like that, or a glove. So this kind of ensures that if you're going to sign off, it's not a rubber stamp. You actually wander out to the work site and you look and say, yeah, I'm comfortable that this was cleaned up properly and signed it. Yeah, and under anything that has ammonia refrigeration, the whole management of change under PSM gets very regimented, and so it was real easy to just take that discipline that you already had to use and apply it to pretty much everything at the plant. So anything that struck an arc, created a spark, required a hot work permit, so that again, you weren't burning the plant down or causing damage. So yeah, that would have been your steam inlet right there. And the steam valve that would open and close to let the steam when it needed it. So there are some fundamental components on here already that the only reason I frown about oven 9 being that poster child is because we have such a low RPM motors and low heat permitted airflow. Now, if we follow through and get oven 10 rocking, that one could be the perfect poster child. The bad part is that that's the one you already spent money on trying to get it up there. So, in my opinion, it would be a big loss. Once you see Mike's system, did you have a chance to call him? Okay, because he's expecting your call. Yeah. He said he would make it a priority to fit your schedule and get out here and go back down. Let's go over to another bank, and there'll be another set of topics to talk about.